Hello dear students, welcome back to our YouTube channel Physics with Jagan sir, and this is your Jagan sir, and we are going to discuss Newton's laws of motion third class, and we have successfully completed first class and second class. In the first class we had discussed what is Newton's first law, what is Newton's second law, and in the applications linear momentum and its applications also we have seen in our first class, and in our second class we have seen how to draw the free body diagrams. And for different forces, how to draw the free body diagrams for different forces. And what we have seen, what is free body diagram? Free body diagram means representation of set of forces acting on the object. This is what is known as free body diagram. This is what we have seen in our last class, right? And here it's applications of free body diagrams and dynamics of particles, translational motion of accelerated bodies. Based on this concept, we have here some problems. Let us see, and these are the most important problems, and it will gives you perfect knowledge in representation of the free body diagrams. First point, and second point is these are the conceptual and little bit depth questions. Depth questions means these are the application orientation questions. So we will see one by one. Three blocks A, B, C of masses M1, M2, M3. That is, this is block A, this is block B, this is block C, and its mass is M1, its mass is M2, its mass is M3, respectively, are resting on one top of the other as shown in the figure. A horizontal force F is applied. F is applied here. F is applied on block B. Assuming all the surfaces are frictionless, calculate acceleration of block A, block B, and block C. See here, this one is moving in the forward direction, and there is no direct force is acting on A block or C block. There is no direct force acting in the horizontal direction for A block and C block. Therefore, acceleration of A and C blocks in horizontal direction is equals to 0. And similarly for block B, and set of all the forces acting is equals to mass into acceleration. Right, what are the set of forces are acting here? Only F, external force is acting, which gives an acceleration AB. Therefore, acceleration of block B is equals to F by M2. F by M2. This is what is first option, answer for first question. And B question is normal reactions between A and B, A and C, sorry, B and C, and C and the ground. That is, this is block A, and here normal force acting on this block due to normal force on A due to B block. And in vertical direction, apart of normal force, do we have any other forces? Yes, gravitational force is present, M1G. Right? Now, set of all the forces acting about y-axis is equals to mass into acceleration. Now, mass, the N1 is representing in the upward direction, M1G is representing in the downward direction. And for this particular block, we consider for upward as positive and downward as negative. That means N1 minus M1G is equals to M1 into, there is no acceleration of the block, so 0. This gives N1 is equals to M1G. N1 is equals to M1G. Similarly, for second block B. For second block B, C, for every action, equal and opposite reactions will exert. So N1 due to block A is acting on block B. Similarly, because of block C, N2, normal force between B and C, B and C, right? Now M2G is acting in the downward direction, M2G is acting in the downward direction, right? Now set of all the forces acting is equals to MA, right? Set of all the forces, upward direction I have to consider as positive and downward direction as negative. N1 minus M2G is equals to M2 0 because the object is at rest position and it is not moving in the vertical direction, so acceleration becomes 0. Then N2 is equals to N1 plus M2G, and N1 value we have seen as M1G, M2G. This is what is N2 value. This is what is N2 value. Similarly, for block C, and here M3G, and this is N3. N3 is the normal force between block C, block C and ground. Block C and ground. And for every action, equal and opposite reaction is exerting. This N2 is the normal reaction due to block B on block C. And remember, very important point is here I am representing what are the set of forces acting on the object, not by the object. And N2 is acting on the object by the block B. N3 is acting on the object by the floor. M3G is acting due to gravity. Right? Now, similarly, set of all the forces is equals to M, A, Y, and N3 is acting in the upward direction, N2 is acting in the downward direction, M3G is acting in the downward direction is equals to 0 because the acceleration of the block on the y-axis is 0. Next point, here N3 is equals to N2 plus M3G, and N2 value is M1 plus M2G plus M3G. Ultimately, N3 is equals to M1 plus M2 plus M3 into G. This is what is the normal reaction between the floor and the block C. Right? This is what is the solution for the first question. Now, let us see the second question. Three boys, each of mass 45 kg. Each of the mass of the boy is 45 kg. Pull simultaneously a block on a smooth surface. The mass of the block is 20 kg. See, this is with 20 kg. Find the acceleration of the block. See, the most important point is this is F1, this is F1, this is F2, this is F3, this is F3. Now, it is making an angle 45 degrees. It is making an angle 37 degrees. So it is having resolve. We can resolve it into two components. One is horizontal component. One is vertical component. The horizontal components becomes F1 cos 37, F1 sin 37, F3 cos 45, F3 sin 45, and this is F2. This is F2. And here along x-axis, set of all the forces acting is equals to mass into acceleration on the x-axis, which they are asking. Find the acceleration of the block. Right? Now, force on the x-axis are F1 cos 45, sorry, cos 37 plus F3 cos 45, and apart of this, no other forces are acting on the x-axis, right? Which gives mass into acceleration. Now, F1 value they represented as 90, cos 37 is 4 by 5, F3 is 128 root 2, this is 1 by root 2, mass is 20, acceleration is Ax, right? Then this is 1872 plus 128 is equal to 20 Ax, which is 200 20 ax. So ax is equals to 10 meter per second square. This is the acceleration of the block about x-axis only. About x-axis only. Let us see for y-axis. Along y-axis, and what are the forces which are representing in the upward direction we have to consider as positive and the downward direction as negative about y-axis means. Now upward direction forces are F1 sine 37 minus r. F2 is representing in the upward direction, F2, and minus F3 sine 45 is equals to mass into acceleration. Mass into acceleration. Now F1 is equals to 90 into 3 by 5. F2 is equals to 114. F3 is equals to 128 root 2 1 by root 2 20 a by 20 a by. Now which is equals to 1854 plus 114 128 minus 20 a by 20 a by, and which is equals to 11454 168 128 40. This is 40 is equals to 20 into a by acceleration about y axis is 20 meter per second square, right? So net acceleration is equals to under root of ax square plus ay square, that is 10 square plus 20 square, which is equals to 500 or 10 root 5 meter per second square. This is a bit, and let us see for the b bit. Let us see solution for b bit. Find the acceleration of the boy exerting a force F1. Assume no friction between the boy and the surface. So for boy, F1 is equals to ma, because they are asking the acceleration of the boy, which is for the force F. So 90, and mass of the boy is 45 kg. A is equals to 2 meter per second square. 2 meter per second square. This is the solution for the second question, and I hope the concept which we were discussed, is just giving information how to represent. But the problems which we are solving are application orientation problems. These are the concept where we are using. This is what the application, and that to be we are discussing some analysis, critically analyzing questions. These are the critically analyzing questions we are discussing, and my aim is to make you to be more comfortable with the subject, right? And third one is, let us go with the third question. A block of mass m is placed on a horizontal surface. If the block is pulled by applying a force of magnitude phi F is equals to phi mg, that is phi mg is the force applying here at an angle of 37 degrees. At an angle of 37 degrees with the horizontal as shown in the figure. Find the acceleration of the block at the given instant. Right now, here phi mg cos 37, phi mg sin 37, and it is placed on the floor. So mg will act like this. Right now, along x-axis, finding acceleration along x-axis, and similarly normal force will also exert here. Now sigma f is equals to max. What are the forces acting on the x-axis is phi mg cos 37 is equals to max, and apart of this no other forces are acting on the x-axis. So get cancelled. 5 into 4 by 5 ax. So acceleration along x-axis is 4 meter per second square. 4 meter per second square. Right now, about y-axis, about y-axis, see here, most important point is 5 mg sine 37 is equals to 5 mg 3 by 5, which is equals to 3 mg, and this 3 mg is obviously greater than mg. So upward direction force is obviously greater than downward direction force. Therefore, object will lose contact with the surface, contact with the surface, right? Therefore, sigma f about y-axis is equals to may. And what are the forces are acting here? 5 mg sine 37, and normal force is okay, we can write initially minus mg is equals to may, and since it is losing contact, n is equals to 0, n is equals to 0, right? Then 5 mg 3 by 5 minus mg may, then this becomes 3 mg minus mg may 2 mg may, then ay is equals to 2g. Ay is equals to 2g. Acceleration about y-axis is 2g. And this is what is the, and see here, net acceleration of the system is equals to ax square plus ay square, and we got ax value as 4 meter per second square. Actually, see here, here g is also present, g is 10, so which is equals to 40, right? Here this is equals to 40 square plus 20 square, which is equals to 2000. 2000 means 10 root 20 meter per second square. This is the net acceleration of the system. This is the net acceleration of the system. And next one is, and this one is one of the most important problem. Most important problem it is, a smooth box of mass m is kept on an inclined plane of angle of inclination theta. The force F is applied on the block in horizontal direction as shown in the figure. The first one is, force F is acting on the block in the horizontal direction. F is acting in the horizontal direction, and it is theta. It is theta in the horizontal direction as shown in the figure at an angle phi with the inclined plane as shown in the figure 2. For the first one is, if the box does not lose contact, find the acceleration of the block. Here the block is not losing contact, that means it remains attached to the inclined plane. Now, what would be the acceleration of the block? The acceleration we can find, see very carefully here how I am resolving the components. Here I can draw like this. I can draw like this, and here this is theta means obviously this will be theta. If it is theta means this will be 90 minus theta, again this will be theta, again this will be 90 minus theta, again this will be theta, and again this will be theta. This is the resolving theta values for the given situation. It is one of the most important representation. It will help you enormously if you are familiar, if you are strong in representation of angles, then resolving the components is very easy, very easy. That means, see here, this is actually mg is acting in this direction, mg is acting in this direction, and this is making an angle theta with this vector, means this will be mg cos theta and this will be mg sin theta, right? Exactly perpendicular one will be mg sin theta. And here this f will have two components, f cos theta, because f is making angle with this vector, so this vector should be cos theta component, f cos theta, right? and again plus this will be f sin theta and normal force n. And they are asking only acceleration. The block is not losing contact with the inclined surface, means the block will move in this direction. So we consider in this direction as the positive, right? From this point, left downward direction as positive, left and downward direction as positive, upward direction as a negative, right? Now see, along inclined plane, along inclined plane, see here, set of all the forces is equals to MA along the inclined plane. Set of all the forces is equals to MA, and along the inclined plane, what are the forces are acting? Mg sin theta minus F cos theta is equals to mass into acceleration. And apart of these two forces, there is no other forces acting according to the question, right? Then acceleration is equals to mg sin theta minus f cos theta by m by m. This is what is the acceleration of the block, right? Next, normal reaction offered by box on the inclined plane. Now B bit is what is the normal reaction acting. Now a perpendicular to the perpendicular, it is loading, give some time. Right, perpendicular to the box. See, perpendicular to the box means normal force exerting in the upward direction, mg cos theta and f sin theta is acting in the downward direction. So, normal force mg cos theta minus f sin theta is equals to mass into acceleration sigma fy is equals to ma, right? So, object is not losing the contact, means it is not moving in the vertical direction, that is perpendicular to the inclined plane. So acceleration remains 0. The normal value becomes mg cos theta plus f sin theta plus f sin theta. I hope it is very clear. Now let us find the acceleration and normal reaction for the block for case 2. Case 2. See, case 2 is, this is the block. Over this block, force is acting like this by making an angle phi. That means, can I say this is the vector with which it is making angle, means f cos phi, and this will be f sin phi, and this one will be, again as I told you, right, this will be mg, and this is the angle making, because it is theta, means as I told you again and again, this will be theta. If it is theta, means this will be theta, again this will be theta, and again this will be theta, and mg, and this will be mg cos theta, and this will be mg sin theta, right? And n f, right, 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 along parallel to the inclined plane, along parallel to the inclined plane, can I say this one is positive and this one is negative, mg sin theta minus f cos phi is equals to max. Let us assume this is x-axis, this is y-axis, similar to the last one also, last question also, last part of the question. So acceleration about x-axis is equals to mg sin theta minus f cos theta cos phi by m. This is acceleration of the block along the inclined plane. Now second part is perpendicular to the perpendicular to the inclined plane perpendicular to the inclined plane. See here, normal is acting in the upward direction, f sin phi is also acting in the upward direction, mg cos theta is acting in the downward direction. N plus f sin phi minus mg cos theta is equals to, it is not losing the contact, so it is not getting any acceleration, so acceleration becomes 0, m 0. Then n is equals to mg cos theta minus f sin phi. Right, this is what is the normal reaction due to inclined plane on the block. I hope you understood very clearly, and this is the last question. Right, this is the last question, and if you have any doubts you can comment me, you can send the doubts in the comment section. And for daily practice papers and weekend examination papers, I am going to post regularly from now, from this week onwards actually. Better to follow our YouTube channel Physics with Jagan sir. Sorry, for daily worksheets and weekend examination papers, better to follow our Telegram channel Physics with Jagan sir. Have a great day, take care, bye bye.